We want to look at differentiation. We want to start by talking about the context behind differentiation. Mainly, we want to look at why do we use differentiation. For this, let's first recall how do we find the gradient of a straight line. Now we know gradient of a straight line is constant and we can find it using the following formula y2 minus y1 by x2 minus x1. So we take these 2 points and using this formula y2 minus y1 by x2 minus x1, we can find the gradient of a straight line which is constant. But now, unlike a straight line, gradient of a curve is not constant. And to find gradient of a curve at a point, we use what we call tangent lines. A tangent line is a line that just touches the curve at one point. How do we use these? Let's see. Say we want to find the gradient of the below curve y is equal to fx at x is equal to x1. So what we'll do is we'll use the concept of tangent lines to find the gradient of the curve at the point x is equal to x1. We can find the gradient of the curve at x is equal to x1 by drawing a tangent line at x is equal to x1. Remember, a tangent line is a line that just touches the curve at one point. So if I want to draw a tangent line at x is equal to x1, it will just touch the curve at x is equal to x1. And then we can find the gradient of this tangent line using the gradient formula of a straight line, which we just looked at, y2 minus y1 by x2 minus x1. So if I want to find the gradient of this curve at x is equal to x1, we draw a tangent line to the curve at x is equal to x1. This will be a line that just touches the curve at the point x is equal to x1. And then we can find the gradient of this line using the gradient formula of a straight line, where we can use the gradient formula of the straight line to find the gradient of this line. So the key takeaway from this at least is that if we want, we know the gradient of a curve is not constant. So if we want to find the gradient of the curve at a given point, such as x1 in the figure before, it would be the gradient of the tangent line at that point, where a tangent line is a line that just touches the curve at that one point. But the problem arises that this is not a very accurate method. Because see, if we're doing it like manually, if we're manually drawing a line at a point on the curve and then we're finding its gradient, this is not a very accurate approach. Right? So this is where differentiation comes in as an alternative to the graphical method to find the gradient of a curve at a point. The graphical method is correct, but it's not very accurate. So that's where we bring in differentiation, which is a mathematical method of finding the gradient of the tangent line at any point on the curve, which gives us the gradient of the curve at a point. Because remember, so basically differentiation allows us to find mathematically the gradient of this tangent line at a point on the curve, which gives us the gradient of the curve at the point. So in short, the derivative at a point on the curve is the gradient of tangent line at that point on the curve, which is equal to the gradient of that point. Sorry, gradient of the curve at that point. Because remember, the tangent line's job is to tell gradient of curve at a point. So instead of graphically us drawing a tangent line to the curve at that point and then ourselves calculating the gradient of this line, which won't be very accurate, what we can do is we can use the concept of differentiation to find the gradient of tangent line to the curve at a particular point to get the gradient of the curve at that point. So in short, when you want to find the gradient of a curve, method one is you can use graphical method, which is accurate, but not, sorry, which is correct, but not very accurate, because you would have to draw a tangent line and then find the gradient of that tangent line. So alternative to it is a mathematical method known as differentiation. So that is where differentiation comes in. It allows us to find the gradient of the tangent line to a curve to find the gradient of the curve at that point.